you see in one beaker a graphite felt cathode in a 0.5 molar H2SO4 electrolyte bath. It also has 0.1 molar manganese 2 sulfate monohydrate. That's a redox shuttle. More about that in a future video. Now look carefully at the one on the left, the first beaker on the left, and what looks like some deposit on the cathode. We use the DC power supply, and that is presumably mixed species of manganese plus 2 and manganese plus 3 oxides. Now we'll confirm that with scanning electron microscope and micro XRF, and we should be able to get some information on that. It's serving as a not a scavenger electrode, but simply a cathode where hydrogen is being produced. We're interested in what's in the other beaker, and you can see the difference in coloration. The one there on the right is oxidized graphite felt, and in the oxidizing, electrochemically oxidizing bath, that is your anode, where the graphite felt is oxidized. It's creating hydroxyls, aldehydes, ketones, epoxides, carboxylic acids. The reason we're doing that, it will serve as a secure anchor, we hope, for the subsequent deposition of the organic conducting polymer polypyrrole. But that will be future experiments. And the reason it's darker, when you start, the graphite felt is usually a gray. There's a big difference between the two. You can even see it there before and after this run, the difference coloration. Because when you disrupt the pi network of the graphite, which is, of course, conducting, you're disrupting and spacing fibers with the oxidation, letting more visible light in, hence the black color. Also, we started this, the electrode areas are about 3.5 by 5 centimeters. Now, of course, there's the thickness. We usually use graphite felt at about 0.9 millimeter, 1.1 millimeter thickness. So there is substantial surface area. But starting at 5.0 volts, potentio galvanostatic, constant current, 500 milliamps. The initial voltage was 5.0 volts. During the course of 45 minutes at 22 degrees Celsius in the lab, we saw hydrogen evolution at the cathode. We saw the graphite felt turning dark. The plating bath went from colorless to a light yellow color. That's the manganese species, which helps to create more uniform oxidation on the felt. And at the end of 45 minutes, we stopped. And the voltage had gone up to 5.9 to 6.0 volts because the resistance is increasing with constant current. The graphite felt becomes less conductive. We're disrupting the pi system. But we will find, we hope, the polypyrrole polymer will deposit and be anchored more in place with the oxidized moieties on the graphite felt. Now, if you look at the slide on the right, the two electrodes are simply soaking in distilled water. I'll leave them there 24 hours. I'm working on this with two of my undergraduate students, and Alex and Jay. And you see those pencils. What we find works for this scale, we take pencils, number 2, we sharpen them up, we cut them in sections, we burn off the wood, and if you look carefully at those two electrodes on the left, the sharp point can be inserted directly into the graphite felt, and they serve very well as leads for attachment to the DC power supply. It works very, very well. I've inserted one, and you can see a sample of gray unoxidized graphite felt. You see how gray it is now? Compare it to the one that's black in the first image. And that works fine. I have tried many different approaches to coming up with these leads. I'm getting in titanium wire. I'll try that as well. But for us, this is fine. Now, when we increase the size of the electrodes for deposition of polypyrrole, we will use a titanium electrode as cathode, and I will also use carpenter pencil, flatter graphite felt and thicker, and just with a Dremel tool sharpen it to an arrow for insertion. But it holds up and it works well, and we're getting uniform coloration, which is, of course, very desirable. I'll have the students also run a bath with 0.5 molar sulfuric and not use manganese sulfate as redox shuttle. And with the scanning electron microscope, we'll be able to see what difference, if any, there is. Thanks for watching. We'll keep you posted. Bye for now.